So let me start from a short introduction. My name is Dmitra Levashova. Originally, I am from Zaporizhia, and well, almost 16 years ago, I was graduated from a cathedra of appliable math. So basically, we're kind of colleagues with you. Since then, I'm working with data. And today, Dmitra asked me to give this tutorial about PySpark, as it is one of the most popular frameworks for processing data, and we widely use it in my current company. So I think it will be interesting for you to know about it. He assured me that you are already professional with SQL. And while preparing to this session, I understood that it would be too short, that I will just compare two languages and that's it. Or it will be too long and I'll need to go in details that you don't really need until you will become data engineers. That's why I decided to do a mix. So first of all, I'll start from pretty broad concepts. Then I'll talk a bit about why actually how databases optimize queries, what is database, how it optimizes queries, and what is going under the hood and what is important to keep in mind. Then we will compare SQL and Spark. And in the end, I'll show that Spark goes a bit beyond the working with the data, with pure working with data. Actually, how can you run models on Spark cluster? Okay, so let's start. And let's start from the most general
Sorry,
thing.
Dmitra.
Sorry, Dmitra?
Maybe you're sharing the wrong monitor. Because it's
Perhaps.
in
What do you see right now?
we see like the two presentations like for the
Okay,
speaker.
let me then change it. Okay. No, I'm sharing the right one actually, but for some reason it goes wrong. No. No. Okay, well, that's pretty strange. Let me share the second one and then tell me, second screen, tell me how it would look like. Is it better?
It's vertical. Maybe the previous one was even better. It's not a big deal that we see the next slide, I think.
Okay, I propose then to follow non-ideal scenario. I will not share screen. I will share screen itself, but I will do it not in presentation mode, but like this. Would it work?
Yeah, it's the best option, I think. Okay, thank you.
Okay. So, yeah. So let's think about nature of data, and yeah, well, basic idea we all understand that all things around can consist data, and we can that actually we can work with. So it might be some multimedia information about how it looks, how it sounds. It might be some documentation, text data, stories, etc., etc. It might be some observations, some transactional data, some maps, so data is around us. But the most general classification tells that there are two groups. First is unstructured and structured data. Honestly, this is not really strict because every time we try to work with unstructured data, we are looking for something that could structurize it. And structured data is just easier to work with. And this is the most common case what companies use for their analysis and for their modeling. Actually, there are pretty strict way of distinguish those types of data is saying that unstructured data we usually store in files, and then we build something on top of it. And structured data we can put directly into a table. Well, in reality, it's not so strict because we have something intermediate called documents. So it's when we save transactions where no one guarantee that the structure would be as we expect. So we can put any field there and then work it using just properties. And reality goes even beyond that, because any file system you could use for organizing your data is actually a database that helps you to operate with this data. And any table that you will use in production, it's actually a file, where again, as a SQL and database is just a wraparound that helps you to find data inside and work with it. If we actually think what is database, it's just a wraparound which help us keep relations, that provide us language. So basically, we can work with data having direct access to memory, but that's not so efficient. And let's be honest, for really critical cases, we don't want to take that risk. It's optimization to allow people with lower skills to do more complex job, basically for simplification. And that's of course security and control, because data access should be managed, and yeah, well, the databases provide that from the box. And if we talk about data in production, there are only well, not only, the most common things in production are two types of data. First is master data, information about properties. So it's who are your customers, what are your products, what weather outside, etc., etc. So everything that all properties you can find about entities. And then transactions. Basically, this is an action that agents in your system do. Usually it goes as sequential data, and yeah, well, this is what we work with commonly. And of course, both of these two types perfectly fit in tables. And if we look on a broad market of databases, there are two approaches how table databases could be organized. This is row-based and column-based. It's pretty simple. It depends on how the data is stored there. In row-based, we store it per row. In column-based, we store it per column. And why actually this is important? Because like how to visualize that? If you had a course of C++, you remember that all your arrays are stored as first as array of indexes, and then actually an array. And when you want to do anything with this two-dimensional array, you need to access data somehow. And basically, there are only two main operations that database supports how we can actually estimate performance. This is retrieval, selection data, and input data, actually how we store it. And these two systems execute those operations differently. If we go to retrieve part, then for row database, we select it per row. We can't select a specific column. We just take all rows that we want to use. For column-based database, it's we can select specific rows, but then we select a whole column. You might ask why actually this matters, but just think if you have several thousand rows, several million rows and and several thousand columns. So tables could go to terabytes of data, and if you need every time select everything to filter some context, well, you will be in trouble because it's not efficient. You need to feed it into memory. The second operation is inserting data, and here we are in pretty opposite situation. So to add extra row to row-based based database, you just need to add an extra row to a two-dimensional array. You just write it. And if you want to do the same to column-based database, you need to add separate elements to each individual column. So it's pretty costly. So basically, this is two trade-offs, and row-based databases much better perform much better in writing things. Column-based database is really good in reading things, and generally for analytical purposes, and analytical, I mean for analysis, data science, reporting, etc., column-based databases are much more widely used, just because of size limitations. Also, do you have any questions about this part? No? Okay, that's great. Let's move forward. Next, I want to talk a bit about optimization, actually. How there are two tricks that are pretty widely used in almost all databases, and you should be aware of it just when you work with data, so you can optimize your work and performance. So first question is, what can we do to search through a column faster? Because in general scenario, you have a row with values. To find a certain value, you need to go through all cells and compare it with value you have, the value you want to find. And this operation costs usually n tries on average. The trick is that it could be optimized in a case if we can order data. And if we can order data, we can build a binary search tree on top of it, which is graph, where on a one each node is a value in your array, and it's just sorted. On the left side, it's all values that are lower. On the right side, that are greater. Using this graph, you can search through the same column using log and complexity. You don't need to memorize. I hope no one will ask you on exams about it, but this is just something you should keep in mind, that indexing is something that could significantly perform your boost of the database. Next optimization thing I would like to share, it is partitioning. And the question is, what if we have so much data that we can't actually fit it into memory, and we want to be efficient in filtering it? Solution pretty simple. We just take a table, we take database and split it to different tables. Using the column we want to use as a partition. The most common thing to use is dates. So we have separate table for today, separate table for yesterday, and so on, so on. Cool thing to have. We don't need to load every time all tables in memory, so pretty efficient. This is two basic concepts that are integrated in almost all databases, and also in Spark. It's work automatically. Most of you wouldn't work with it closely, wouldn't build it, but at least you need to be aware, because filtering and writing to database based on these fields significantly boost performance. Okay, so this is the end of general part. Do you have questions? No? Okay, great.
No.
Sorry, Dennis, did you told anything?
No questions.
No? Okay. Okay, then let's move further. Actually, we are coming to Spark, and first question is why? This slide I took from a presentation of Spark from their website, and it's fully commercial. And yeah, don't even try to read it because it's too generic. There are several things we do need to remember about Spark. First, it is open source. That means that it's maintained by community. There are different implementations, and it's basically free or almost free because you still pay for a server where you will execute it. Second thing, it is extremely efficient. It's from the box, it does parallel processing. It has great optimization, query optimization under the hood, so you can write non-optimal queries and Spark will optimize that, which actually not always good because it has too many possibilities for optimization. That's why quality of code drops, but still it's better to have rather than not. And generally, it's a great system to work with, especially if you know SQL or basic syntax. And as I mentioned, Dmitra already present you as people who are familiar with SQL. So I propose to look on it in a comparison between SQL and how would it look in PySpark code. Please look on a screen, and here you see an example of query that use base operations. It's select data from source table, it's joined it with another table, it aggregates. Is everything in this query clear for you, or is it better to explain how it works before we will go further? Okay, I suppose that everything is clear. If we write the same query in PySpark code, it will look like that on the right side. It will be a bit longer, but generally we use pretty the same syntax. The core difference is that when you work with SQL, you have really stable structure that you fill, and then database itself interpret it. So you have tables you select from, and they are in a specific place. They are always there. You have varchars where you would define the conditions and filtering, and it's always after joins. You have fields to select and to compute, and they are always on top, etc., etc. So for SQL instructions, you have really step-by-step defined structure where you can put it. For PySpark is not so strict. You actually load data, and then you work with it as with objects. Objects has properties, you send and methods, you call methods, you send there some parameters, it optimizes it, etc., etc. Important thing to mention here that PySpark use lazy load, so that if we will run code on a right side, till we run show, it will cost us nothing. So it wouldn't do any computations before actually you will say that, okay, please execute, or please save the result, or cache it, or so do whatever you want with it. That could save a lot of time, but that also helps PySpark optimize that pipeline, because it doesn't compute on every step. It's take everything together, and if you will filter not on early stage but later, it's fine. It will accept it and work with it. And as soon as you call execution command, it might be show, it might be save, it might be convert to some local data frame. It will execute the pipeline and you will get the result. Okay, now let's go further and actually see how different parts differ between SQL and PySpark. Well, the base thing to have is how we access source of data. In SQL, that's always from. In PySpark, we just say that we have variables that relate to a certain table or certain data frame. Next one, select. Here we have a bit more differences because in SQL you put all fields to select with and you don't really matter if it text, if it's operation you want to perform. For example, if you want something, some new field, you can easily say S1 A plus S2 B. Let me make it black. Yeah. In PySpark, it's separated. So if you want to select a field that already exists, you use select method. If you want to add new column or do some computations, you call method called withColumn, where you set a name and you defined what actually you want to do and how to compute it. You can strictly use just another column when you want to rename, or you can recompute or a field that already exists if you want that. Actually, just to keep consistency, when you want to rename in SQL, you put exit instruction as new name. Next one, join. I would say that it looks really similar. So in SQL, we have our main table. We give type of join and another table we want to join. We define fields that on which we will join, and it works. The same it works in PySpark. So you have data frame, initial data frame. You can join it with second one, with aliases. You define field on which you join, and you say what type, left, right, inner join. The problem is that Spark supports more than 10 different types of joins. And honestly, I never use anything else rather than left, right, full, inner, and cross. And that pretty stable you use in SQL. And honestly, I do advise you not to use tricky joins, just because not all people, when other people will read your code, will understand what actually it will do. And readability of code is a really important thing because someone should maintain it after you. Okay, workers. Strict like that. So in SQL, you say that you want to filter certain conditions, you set it. In PySpark, you do the same. You call method, and then you call it, and then you put their expression in the same format. Column name, condition. If you want to send several, you can do that. You just put several new instructions. You put and you write something here. Next one, group by. And here again, minor difference, because in SQL, group by calls split it in two parts. First part, you put what to compute in a select, and fields that you aggregate should be also in a select. and then you put everything that shouldn't be aggregated, basically aggregation field in a group by condition. Here you do the same. You say group by which and list of fields that you need to do. And then what operation to compute on those subsamples. Here I want to count and also take some sum. What differ is actually extension of group by is having. In SQL, we can use it to apply filtering to already aggregated data without putting it to select condition. In PySpark, there is no such option. You need to compute this field and then use where method to filter those. And last but not least is order by and limit. So basically a method that uses SQL, you defined which columns, how it will be decreased, descending or ascending order. If you want to use several columns, that's also fine. You just separate them by column and set separately by ascending or descending should they be ordered. In PySpark, it's use the method called sort, not sort values, where again you send a column which you want to based on which you want to order things, and that's it. Limit works the same as just to see top n things from your data frame. But the beauty about Spark is in a different thing, that if you want to use SQL and you like it, PySpark still allow you to use it. Just use spark.sql, put your query there, and it would work. And it would work really good. Okay. Sorry, could you repeat a bit loudly? No? Okay. Okay, last but not least is that Spark itself could run ML algorithms there. And I was looking for a fancy picture to put here, but in the end, it does it almost the same as any environment. So you can run it. The only difference I found that it strictly requires vectorization. It gives a bit weird look for data, but nothing really critical. It's just to convert it to a internal data structure of a Spark. And this is it with our theoretical part. Please ask questions. No? Good. Then I propose to go to editor. And I'll show actually how it looks like on practice, how it works, so we can touch it, see how it's connected, etc., etc. So basic entity in Spark, by the way, do you see VS Code? Black editor with a code in it.
Yes.
Okay, that's great. Let's continue then. So basic thing in a Spark and in a PySpark is a connector. So you execute code not locally, but somewhere on a server. In this specific case, I use local setup because, to be honest, to run Spark server on a Windows machine is not the best idea. But yeah, if you want, you can set up Docker and run it. To load dataset into memory and run into environment, we can go straight like that. So I have dataset in my project, and that's about Titanic, actually, who survived, who died, and I put it into memory. And I can work So after it, for example, if I want to see top 10 rows, the code would look like that. If I want to change this, if I change this value, that would also work. What data we have here today? We have passenger ID, just index. We have fact if they survived or not. We have passenger class, name, their gender, age, amount of their siblings, so amount of brother or sisters which on board. This column shows, if I remember right, it is amount of parents or children. Depend on age, we can define that ourselves. Ticket number, how much they pay, their cabin, and port where they embark. Yeah, so let's work a bit with this data set to see how Spark works. And before we can touch the data, we need to convert we need to convert numerical fields to actually numbers, to integers and doubles, so we can do anything with it. And the code is pretty simple. I go through data. I create a list of columns I want to convert. Then I go through this list and basically I reassign column to the same column, but with different type. I take it was initially string. I say cast it to integer. And what is important to mention here that it takes no time. That's because it's actually convert nothing. It's just create an instruction in a processing pipeline. It's add an instruction that those columns should be converted. That's why it's fast. Then we can filter based on already data set where where all fields would be converted to integers or numerical type. So if we want to select someone with the age above 30, I suppose that they will travel not with parents but with children, if we say greater than 0, in a first class. And here are two blocks. First, we actually create new data set from it, again on instruction level, so there was no execution. And then we show it on execution level. If we wanted to do anything else with this data set, we can easily do that. For example, we can count how many rows it has. Continue. Moving forward, let's look on group by. Here we can check what is how statistics look like if we how our data look like from a perspective of a port where customer embarked. I use group by method where I defined what actually we group by. Then I set list of fields I want to compute. So first I want to compute amount of passengers. Second one, I want to compute percent of passengers that survived, which actually an average of column if they survived. And average price of a ticket. Execution really fast, but we have really small data set. What interesting thing that is not related to Spark but related to dataset, there was certain port where with low amount of customers with oh no, this one actually port where for some reason customer has higher survivability rate than their others. We can't give an answer why is that. Just a funny fact. They paid more. Perhaps it was just a novelty who decided to take top classes. That's why they survived. And let's look on survivability rate per classes. Well, first of all, let me describe how it works. So I do a group by with the same structure, but Spark server itself can't visualize data. So this time I converted to pandas data frame, which is widely used in Python. Say, plot it as a bar chart. And here we see the significant difference between classes, and now we know why those people paid for first class so much money. So they got better chance to survive. Do you have any questions about data processing? No? Okay. Then let's move to our last part, and I'll show actually how model could look like. And here I decided to train something really naive. I took logistic regression and just to show you how processing PySpark looks like. First of all, I defined which features we have categorical, which numerical. After it, I want specific of Spark that it can't work with text features. A lot of algorithms can't do that, but in Spark that's they onboard a lot of methods and algorithms, but unfortunately they did nothing with categorical features, so we need to encode it manually. So first of all, we convert text and categorical feature to numerical. For some things like class, we can skip it, but generally it's better to keep pipeline solid for all categorical, so we wouldn't have problems recognizing what we did. Let's look on sex, actually on gender of a customer, and we had initially males or females. As a result, we got values 0 and 1. Next step would be to take these numerical values and convert it and use one-hot encoding, convert it to basically different column value data. Again, we take an object, we set certain parameters, they're actually input and output columns. We fit it with existing data set, and we got an object that we can apply to our data to transform it to add new columns. This is how new columns look like. It's already looks weird because we used to table view, but okay. What can we do if PySpark feel more comfortable working with this representation? And last but not least is to take all those variables we want to put in an algorithm and group them as ensemble to a vector space. And again, pretty the same interface. We go set input, output. We built an object that could transform our data, apply it, and we get new column. Of course, split to train and test dataset. Good practice is to do that actually before data pre-processing. In this case, I don't use any feature processing that rely on whole dataset, so this order is acceptable. Then we identify model and fit it. That's it. After it produced pretty standard interface of probability and prediction, which we can test and, for example, apply area under rock KPI. And here it's pretty good for binary classification, 0.9. Yeah, and we also can work with results of prediction as with dataset. We can group it and see how real survivability was predicted, what is false positive, false negative, etc., etc. This is shortly about it. If you would like to dig deeper and go to how to write your own algorithms, how to parallelize, how to do more complex things, That's also possible, but that definitely goes beyond the scope of this session. That's it on my table. Please ask questions.
Thanks, Dmitra, for very interesting lecture. I have a question. What is the easiest way to set some kind of test bed to test Spark for ourselves, better for free?
Repeat, please. To run Spark or to pass data to Spark?
To run Spark.
The easiest way is to use Databricks. Basically, it's a wraparound Spark that automates a lot of processes, and it also provides a web interface for with notebooks. It provides interface for pipeline optimization, for databases, for everything, and it is open source. We use it in our company, and well, it looks pretty good. I can't show you the setup because of policy of company, but it's if you ever worked with notebooks, you will see that it's really similar and works from a box.
Okay, thank you.
Yeah, any other questions? Okay, then I suppose that then this is it. If you have no questions, if you'll get any in future, feel free to reach me. My contacts you can take from Dmitra. Yeah, if you would like to have next session, you know where to find me. So thanks a lot for coming. I hope it was interesting. But if you have any feedback or what I can improve, you're also welcome.
Okay, thank you very much again. Hope to see you soon with the new lecture.
Yeah, the topic let's discuss offline.
Yeah,
okay,
sure.
Have a nice day.
Yeah, same to you.
Bye-bye.
Thank you, goodbye.
Bye-bye.